Hi, so right now I'm in the PLC lab of BCIT, and here we have the 5330 Allen Bradley PLC controller. And so in BCIT, they use this model of an elevator to teach students how to use a PLC. And here we have the model of the elevator. So this white strip right here represents the elevator, and we have these optical detection here to detect where the elevator actually is. So we have second floor, third floor, fourth floor, and first floor. These are the push buttons that call the elevator from outside on different floors. We have fourth floor, third floor, second floor, first floor. This is the inside panel of the elevator that you would actually see when you get inside the elevator. We have push button to call the destination for the elevator. Have the open and close for the door. This is the model of the door. It uses a pneumatic actuator. It's normally closed. So when you actuate it, it would open. Yep. And here I created this program to control this elevator module in ladder logic. Different subroutine here to make it easier for people to read. And I'm using AdvancedHMI to control the elevator. And it's also open source, so you don't have to worry about using whatever panel view from Allen Bradley, which costs a lot of money. So I simulate these different call elevator buttons. You have the keep door open, and close door. So let's try it. So right now it's on the second floor, as you can probably see. So I'm calling it to the first floor. Go to first floor, the door is open. After a while, it's closed. Let's call it to the third floor. So it goes to third floor, the door is open and closed. Let's try to use this keep door open button. So I'm gonna call it to the fourth floor. I'm gonna hold the keep door open. So the door gonna just keep open until I release the button. And after 1 second, it will close. So a bit of complexity in the program is when let's say somebody calls the elevator to the first floor, but somebody on the second floor or the third floor calls the elevator when the elevator is moving towards the first floor. So like somebody calls it here, and when it's actually moving down to the first floor, somebody calls it on the third floor and second floor, then it would stop on the third floor first, and then it will go on to the next destination. So let's try it. So right now it's on the fourth floor. I can call it to the first floor, and then I can quickly click the third floor to simulate it. So fourth floor and then third floor. So it goes to third floor, open doors, close door, and I'm not touching anything, and it goes to the first floor. Let's try it again. So fourth floor and then third floor. Go to third floor, door open, door close, go to fourth floor, door open, door close. So I spent 6 hours on creating this preliminary PLC program and the HMI, and that included the time it took me to get familiar with both the input-output module and the HMI software. At this point in time, the elevator can only handle multiple calls from one direction. So if there are multiple users, multiple customers who calls the elevator from both above and below the current floors of the elevator, the program would not be able to handle these calls in the correct manner. So the way I will try to fix this is implement a finite state machines to create some kind of priority system so that the elevator can service all of the calls above or below it first before it moves in the opposite directions. The next thing I need to work on is the HMI, as currently the HMI is
not an accurate physical representation of the elevator. Like I'm using the same buttons to call the elevator from both outside and inside, whereas the real elevator would have buttons on each floor outside to call the elevators and buttons inside the elevators to set the destinations. So uh, those are the things that I need to work on next.